Section 2.6, Other Types of Equation, Part 2 video. In this video, we're going to finish working several examples of different content that you were seeing on the first video. We've got an absolute value equation, and normally you'll split absolute value into two parts, a positive equation and a negative equation. So absolute value is always positive, right? It results in always a positive value because absolute value is a distance. It's a distance from that number back to zero. Okay, so distance can never be negative. Now, in this one, we see we have the absolute value of 8c minus 10 equaling a negative number. Okay, that is a does not exist. You cannot do that. Okay, it cannot, an absolute value isolated all by itself cannot be equal to a negative number. It just does not exist. You can't take the absolute value and get a negative number because it's a distance. It's always positive. Now, let's look at this equation. First things first, we're going to minus 9 from both sides. Okay, it leaves me with 2 absolute value of 5x minus 3 equals, let's see, equals 16. And then we're going to turn around and divide by 2. So that leaves me with absolute value of 5x minus 3 equal to 8. Okay, so you've got that. It's isolated. There's nothing over there. So we're going to write a positive equation and we're going to write a negative equation. Okay, the positive equation is exactly what is there. Okay, the negative equation is exactly the absolute value, but the right side of the equation, we're just going to multiply it by negative 1. So 8 times negative 1 gives me negative 8. Okay? So that's how you get your two equations. And now you solve. So we're going to plus 3. So we'll get 5x equals 11. X equals 11 fifths. On this one, we'll say plus 3. We have 5x equals negative 5. And then we divide by both sides by 5, so x equals negative 1. So here's our two answers. If we were to substitute those back in, it would satisfy the equation. Now, let's look at this. Solve the given equation over the real numbers. Use exact values. So we have the variables in the denominator. I don't like that. So what we're going to do is this. We're going to multiply everything by Q2. Okay, Q2. In doing that, that's going to leave me with 1 minus 9q plus 18q equal to 0. Well, q squared, I should say. We're going to multiply that. Now, so we're going to rewrite it. We're going to say 18q squared minus 9q plus 1 is equal to 0. So we're just going to factor it. So we got 18. What are factors 18? When added together, give me negative 9. Well, it'd be a 6 and a 3. And they both have to be negative. That would suffice. Negative 6 times negative 3 is positive 18. Negative 6 plus negative 3 is negative 9. So we're going to use a thing called grouping. So here's our middle terms split. So we're going to do that, and then we're going to group them as such. And we're going to pull out a GCF, and we're going to pull out a 6q. That's going to leave that 3q minus 1. And since I've got that, parentheses, the other one has to be identical. So negative 3 divided by 3 is negative 1. Positive 1 divided by negative 1 is positive 1. So that gets me what needs to go on the outside of my second set of parentheses. So 6q minus 1 times 3q minus 1 equal to 0. That's our factors. And we're going to set those factors equal to 0. And then doing that, let's see. Make that go up a little bit. So 6q equals 1. Q equals 1/6. Plus 1, so 3q equals 1, so q equals 1/3. Okay, so there's your answers. we definitely know based off the original equation that q cannot equal 0, right? That would be a restriction. Q cannot equal 0, and we didn't get 0, so we're good. Okay? Now let's look at the next equation. We're going to turn around and multiply everything by x plus 2. Now what that's going to do is it's going to allow us to clear our fractions. It's also going to tell us that x plus 2 equals 0. X can't be equal to negative 2, right? X can't be equal to negative 2. I'm good. Now, so that's x times x plus 2. These cancel, so that's plus 20 equals, that cancels, negative 7x. Let's go ahead and distribute that. X squared plus 2x. Let's take the... All right. Well, let's see. We can go ahead and combine like terms right there. That's x squared plus 9x plus 20, right? Equals 0. Now, we can do our x. So it's 20 up top, finding things that multiply to give you 20, but add together to get you 9. We should know that's 4 and 5. So we're going to say x squared. We're going to do grouping. X squared plus 4x plus 5x plus 20 equals 0. Okay? So we've got some plus x. That leaves me x plus 4. That's x plus 4. 5 divided by 1 is positive 5. 20 divided by 4 is positive 5. So x plus 5 and x plus 4 equal to 0. And then we're going to just set them equal to 0. X equals negative 5. X equals negative 4. Okay? And because we know that that isn't 2, or negative 2 I should say, then we know that those are solutions. So all we did was clear our fractions. It gave me this, and then we moved the 7x over. We combined our like terms, and it gave me the quadratic in red, and I factored it, and those are the solutions. Okay? Now, one more on this particular part 2 video, and this is more or less what's called a fancy quadratic. So we're going to make a be the linear term, which is negative 7x plus 3. So if I replace that, that's going to be a squared plus 7a plus 10 equals 0. So I took the linear term, set it to a variable. I said, hey, that's a. So that right there is going to be a squared, right? Now, it's called a fancy quadratic. I used a variable to substitute. So that's how I'm going to solve it. Factors of 10, what multiply to give me 7, well, you know that's 2 and 5. So I got a plus 2 and a plus 5 equal to 0. So here we go. A plus 2 equal to 0 and a plus 5 equals 0. So a equals negative 2 and a equals negative 5. But we got to go back. A is negative 7x plus 3. So let's substitute that back in. And now we can solve for x, what our x should be. So it allows us to go between it. Okay? So we're minus 3. So negative 7x equals negative 5. X equals 5/7. Okay? And then we're going to minus 3 here. So it's negative 7x equals negative 8. X equals 8/7. So that concludes the solving of the fancy quadratic with just a variable replacing it. It allows us to solve a very simple quadratic now and then substitute the things back in. So that's a really cool technique.